In this video, we will shortly demonstrate how job submission and specifically job monitoring is working in SCALE.sdm. So what I have here is our SCALE.sdm desktop client, and I've opened a model tab. And within the model tab, I have here the run configurations which I want to submit to the HPC system or start the simulation. So once I clicked on one of the simulations, I can see it here on the right side, and I can choose either to just export as a simulation to my local disk, or I can actually also submit it right away to the HPC system. So once I click here, a job will be started automatically and will generate a HPC job by connecting with the Slurm queuing system on my HPC. I already started a couple of jobs yesterday and today, just in order to demonstrate how this is working. So once I started it, it will be queued in the queuing system. However, I can also see once the job is running that certain information is getting passed on to the user. So I can just unfold this and I can see the different stages where my job is and how they performed. For example, we have here the model assembly job, and it shows a green check mark, which means the actually simulation deck has been assembled successfully on the HPC side. And then the solving starts, and the solving is still ongoing, and the solving is at 84 out of 120 milliseconds. So this is an explicit LS-Steiner job, and I can pass on by using a scripting API some information to the user side here, like the kinetic energy, the internal energy, which might be interesting. I can even pass on a directory and provide here a means of opening the directory, which you can see here. I just jumped into the directory, which is mounted on my local system, where the job is actually processed on the HPC system. So I can directly look into that, and in case of LS-Steiner, I can even go and open that results in, for example, Animator, and look at some intermediate results here and see how my simulation is performing, whether everything is converting, and that's a really nice feature, to be honest. Okay. So this is a running job. I can also decide to cancel the job, so it will be killed in the Slurm system. In here, I have a finished job, and as you can see, in this job, everything worked well. So LS-Steiner terminated normally, and everything has been post-processed and has been uploaded to the SCM system again, and even the result data has been downloaded. So I can obviously also go here and jump right into the directory where I then can work with the actually simulated data in my post-processing tools, or I can go to the result part of SCALE.sdm and look at the results there. So I have a couple of other finished jobs, so I might just remove them here from my list of jobs. And I also have a failed job here just for demonstration. So in case anything fails in the process, the information is getting aggregated to the top level. So I can see already on the top level that there has been something that has failed. And I can dive in to see a little bit more about the problem. And I see here an error message which says not for all components a mask was available in local. So this means in my process, I need that the user provides a mask for each component, and this has not been done for some of the components. And in case I want to see what's going on, I can, again, just hop into the directory and dive into the log files and try to investigate what the problem is with this simulation. So that's basically how job monitoring works. We have a very elaborated API for the scripts that run on server side to provide this information to the actual client side, and there is a lot of customization involved, but it has a real benefit for the user.